So number 7, we're asked to make a dot plot. So the low number here is 10, the high number is 20. So I'll just do that, 10, 20, get a 15 in there, then split it up, 1, 2, 3, 4. So, it's not perfect, but close enough. That's probably a little too close. 1, 2, 3, 4. And you could label all of those minor tick marks if you want, but I don't think it's absolutely necessary. I'm going to draw a dot with some predetermined spacing here. This spacing here, I want that to be consistent. All right, so when I do, I need a total of 3 of them. When I do the second one, I want this distance to be about the same as this distance. All right, so put it about right there, about right there. I belatedly realized that I should probably move this down a little bit. I apologize because I know we all don't have that functionality, but be mindful of spacing is really what I'm getting at. 1, 2, 3, 4, 5 of those 11. So 1, 2, 3, 4, 5. For 12s, I'm back to 3. So 1, 2, 3. Try to be reasonably consistent. I mean, little variation's okay, but it should have the correct general shape. 3 of the 13s. 2 of the 14s. 2 of the 15s. 2 16s. A 17, an 18, a 19, and a 20. So this looks like it tails off to the left. So here's my dot plot. And that dot plot is showing a right skew. All right, and that's because it tails off to the right. All right. Other possibilities are that it's a left skew, in which case it tails off to the left, or there's no skew because there's no tails, right? Or it's symmetric. It's you could have something. I'll show you bimodal. I'll just throw out an example here. So let's say you have something that looks like this. All right, you see that you have 2 humps in the graph, 2 clusters of data. That would be the bi part of bimodal. All right. You could also have multimodal. Anything more than 2 humps would be multimodal. But this one, I could even say it's unimodal because we have one tall guy there, but that it's also skewed to the right. All right. So I'm not going to ask for that description in this particular graph, but if you had something that ended up being distributed like you see in the bimodal example, then you would want to make that statement. All right, number 8, what seems to be the most appropriate regression model. So I want to put my data in. So I go to regression, 0 to 4, 6, 8, and 10. 185, 183, 156, 79, 61, and 48. All right, so I have my data in, which appears to be the most appropriate based off of the scatter plot. So let's take a look at the scatter plot. Looks like it has kind of a pattern that goes down like that. All right, so you can make a case for a few things. You could say that it's exponential. You could say it's polynomial. Those are pretty good ones to start with. Using the model that you selected, state the coefficient of determination for the relationship between 2 variables. and then state the equation of the curve of best fit, and then do an estimation from there. Well, we only kind of started our investigation, so let's see which one actually has the better coefficient of determination. That's the R² value. So I'd go into regression. I suspected that it's either exponential, so I'll start with that. Exponential. Go back into regression. I got an R² value. I'm going to make a little note at the bottom here. So exponential R² is about 0.926. All right, so let's, oh, I didn't mean to hit the back arrow. Let's change the model. We can do, well, polynomial has the subcategories of quadratic, cubic, and quartic, or at least that's what's stored in here. So let me do quadratic. All right. If I do quadratic, the R² value not as good. All right, so I'll change it up to cubic. And that actually looks kind of nice in comparison to some of the other graphs. So for cubic, I would say R² is equal to 0.981. All right, so that's better than exponential. Let's go quartic. Doesn't look much better than the cubic, 982. All right, so you can go in a couple of different directions here. They're all pretty strong. The quartic slightly edges out the cubic, but I kind of think of it as the tie goes to the simpler function. Right? So if you could sacrifice just even the tiniest smidge of accuracy, but end up with an equation that's easier to work with, that's typically what we would do. Right? So in this case, I would say cubic. Right? Because you're not giving away much in terms of accuracy, but you're getting a simpler function out of it. Right? If this were something like 0.975 for cubic, that's far enough away that I would say, you know what, let's go with the one that's more accurate. But in this case, I would go with cubic. All right. So the cubic model had an R² of about 0.982, 981, sorry. The equation a lot of toggling back and forth here is kind of aggravating, but it is what it is. All right, so y, put a little hat on the y, 0.552 x cubed. Oops. Minus 8.366 x² plus 14.988 x, and then plus 184.857. All right. And like I said, you can make a case for quartic. You can go either way with it. All right. Do a little estimation. Number of survivors after 11 months. So I'm looking for y given an x value. So predict y given x. And I'll put in 11. Confirm. And it tells us that we're looking at about 72.254. Now, obviously, you're not going to have 25% of it survivor, or I can't imagine an instance where you would. So we would just leave it at that and just say, here's the number. But if I was actually reporting this to somebody, I would say about 72 or 73. All right. But for the purposes of getting the question right on a test, we want to put the appropriately rounded answer. All right. So another data entry one. Let me just go ahead and do that. Clear it out, confirm. Clear it out, confirm. All right, so this one's a little messier. 16, 20, and so on. That should be an 18. 45, 55, 70, another 50, 47, 46, 50, 66, 26, and 60. All right. So I have my stuff in there. Now this one is saying which of the following is the residual for a faculty to student ratio of 22. All right. So specifically, the residual for this value now, or this variable. So your choices are to come up with the line of best fit, and then you'd have to substitute in the 22, get an answer, and then subtract that from whatever 22 corresponds to on this table, in this case 47. Better way to do it, go to graph, or maybe not better, but easier. Regression, do the linear regression. There's always a second linear regression model that we use, right? Doesn't appear to really do anything except for putting a line on the graph. But if I go to, well, let me select auto first so I get a better view of the actual distribution of data. It doesn't seem like there's really much of a way that a line is going to fit this data set, but that's not really what it's asking anyway. So go back to regression, and if you scroll down, you see residual plot as an option. So select that, and then you just scroll around until you find the x value that they asked you to find, which is 22. The residual is negative 14.0227. So that would be, oops, that would be this one here. All right, so pretty nice and easy way to do it on the calculator. Then the next one is which of the following is the equation for the line that best fits the data set? So it's going to be a line. Now, fortunately, we already kind of did that. So I'm going to hit that curly back arrow, go right on up. All right. You'll notice that all the choices have hats on them. If there was a choice, let's say the question said, which of the following is not the equation of the line that best fits the data? I would immediately look to see which choice doesn't have a hat on the Y. All right, the little triangular thing. All right, so we call that Y hat. So the calculator won't say Y hat, but we know that that must be included when we write it. All right, so it looks like the first choice is what I want. So, yep, there we go. You'll notice the second choice is really the same as the first choice. It's just the terms are reversed, right? So it's got to be in the correct order. So the model is y hat is equal to a plus bx. So whatever the x is has to be the last term, right? Or associated with the last term. It said line of best fit, so I would not include one that has a logarithm. That's not a line, right? And this other one here, this is a line, but I don't see how you would get that from the calculator. All right, so dismiss the ones that are obvious, that should be dismissed, and then just make sure you're paying careful attention to the form of your answer, not just the numbers themselves.